So speaking about uncertainty makes lots of people uncomfortable. Anytime an economist speaks, that makes lots of people uncomfortable. So if you have an economist speaking about uncertainty, then we get curmudgeon, nihilist. These are the terms that get applied to me, and I'm proud of them. Let me talk about some broad themes, and I am going to be talking about communicating uncertainty, but actually my focus is not on, the communication comes secondary. It's actually, primary focus is actually on the kind of research that people do, and which provides the basis for communication. And I'm going to focus, what's policy analysis? Well, policy analysis is just a general term that describes scientific evaluations of past public policies and predictions of the outcomes of potential future policies. So policy analysis can be any part of science as it's applied to evaluation and formation of public policy. Now, regarding uncertainty, credible policy analysis, and credibility is a very important matter. We've heard that term multiple times, and Susan Fisk talked about trust, and trust, should come with credibility. So if you're going to do it, you should explicitly express the limits to knowledge and just be upfront and transparent about it. However, policy analysis with what I call incredible certitude has been common. So what's incredible certitude? It's a term that I sort of invented. I couldn't find it on Google before I used it in 2011. But here's the point, that people, at least kinds of people that I deal with, I'm going to really focus on what economists do and other social scientists, they tend to make exact predictions of policy outcomes. And it tends to be rare to express uncertainty. Now, there are obviously parts of science that are much better at this, but I'm going to focus on the aspects that I know where expressions of uncertainty are rare. Now, the predictions that researchers make often are fragile. It's not that they're fraudulent. I don't want to, I'm not talking about the same issues as we talked in the previous session. I'm talking about ordinary science that just, you make strong predictions based on unsupported assumptions and limited data. So it's not that it's fraudulent or not that it's actually making errors. It's just that you assume more than you really have basis to assume using the data that you have. And then the expressed certitude is not credible. Okay, so that's incredible certitude. Now the examples, I could go on for many, many hours with examples. The two examples that I'm going to focus on actually are not done by academic researchers, but done by government scientists. And I think, sitting here right in the heart of Washington, these will be familiar to, I think, most of you, even if you're distant from the social sciences. One is Congressional Budget Office predictions, or what they call scores, of the federal debt implications of pending legislation. And I'm going to come back to this, but just to open it now so you see what I'm going to get at. The impacts of new legislation are difficult to foresee, but the CBO makes 10-year point predictions of the budget impacts of new legislation with no quantitative measure of uncertainty. Another example is not on policy forecasting, but rather just on the data that comes out of federal statistical agencies on the state of society and of the economy in particular. So as examples, they'd be like GDP growth rates and poverty rates as economic statistics. Obviously, official statistics like that suffer from both sampling and non-sampling errors. Yet if you look at what the agencies actually report, they typically report only point estimates. Okay? Now, just to show that there are agencies who do this in a different way. So the National Weather Service, I think, is quite wonderful about this, and has been for quite some time. And this is the best expression of uncertainty I've ever seen. You can read it on this slide. This comes from Hurricane Harvey on August 27th of this year in a tweet. And what the National Weather Service said is, this event is unprecedented and all impacts are unknown and beyond anything experienced. I was thinking, after I saw that from the National Weather Service, I was thinking about the almost any policy question. I was particularly thinking about the Republican tax plan going through Congress, and thinking that the Joint Committee on Taxation is supposed to put out a forecast of what's going to happen. And what if the Joint Committee on Taxation were to say this event is unprecedented and all impacts are unknown and beyond anything experienced? That's, someone talked about their wildest dream before. That's my wildest dream, I think. So I'll come back a little later to the Republican tax plan in one further place. A couple of sources for this talk. I've written quite a bit on this. The most accessible, first a book called Public Policy in an Uncertain World, Analysis and Decisions, a 2013 book, and then a journal article on communicating uncertainty in official economic statistics. The subtitle regarding Morgenstern, I don't have time to explain, that was published last year. The distinguishing feature about both of these pieces, both the book and the journal article, is that they're both written in English. And I don't mean by that I was going to write in my father's Polish or Russian. What I meant is that they're not written in mathematics. And I think some of you, it's actually, for someone who grew up, trained in economics and doing very technical work, for many of us, it's actually very hard to write in plain English. I think I've gotten considerably better with it over time. I think I can still learn. Most of my colleagues don't even try. But it actually does take a lot of work. The problem that arises is that if you try to write in English, it's, not in math, it's easy to slip into platitudes and get yourself into a lot of trouble. And when I write verbally, I want to write it in a way as rigorously as I do when I write mathematically. And that's actually very hard. But I hope that I succeed to some extent. Now, why? I'm an economist. Economists always talk about people reacting to incentives. So why is it that people, the researchers express certainty when they really should be expressing uncertainty? And I think there are some obvious reasons. One is that inside the scientific community, we reward strong novel findings. And then particularly with policy analysis, the public wants unequivocal policy recommendations. So there is this, in terms of, here's my anecdote. It may not be true, but it's nice anyway. I've been using it for many years. Supposedly, when Lyndon Johnson was president, he had a meeting with his economic advisors and asked them to make a forecast about something, GDP growth or something, and the economist is supposed to have said, well, we think it will be in the range 2 to 4% or something like that, and Johnson is supposed to have replied, ranges are for cattle, give me a number. And that is the attitude of many people. They just don't want to hear any uncertainty. They just want a number. Now, I talk about incredible certitude. In my book, the 2013 book, I go through a typology of incredible certitude and then do case studies of each one. Let me just very quickly, conventional certitude are things like the CBO scores and official statistics. They're statistics that are estimates that are accepted as true by society by and large, but they may not be true. It's like a conventional wisdom. And I'll come back to that. Dueling certitudes, I think everyone is familiar with around Washington, is you get dueling studies. You get advocacy and debates, and they go back and forth. The example I use is from 20 years ago, I chaired a National Academy's Committee on Illegal Drug Policy, and our main job was to adjudicate a very tough fight between the RAND Corporation Drug Policy Center and an Institute for Defense Analyses. They had absolutely opposite conclusions about what's going to be good illegal drug policies, particularly regard to cocaine, whether it be drug treatment on the one side or law enforcement and military things on the other side. And they just fought each other, fought it through. Conflating science and advocacy. The example I use in my book is a historic example of Milton Friedman's advocacy of school vouchers back in the 1950s, but I will update this one again to the Republican tax plan, because there was actually quite a wonderful article in the New York Times this past Monday about how the Senate leadership, they know what they want to come out, which is that after the new tax plan is passed, that there won't be any increase in the federal deficit. So they want that as a conclusion. The question is, how do you justify that conclusion? This is where the conflating science and advocacy comes in. So what the New York Times quoted someone from Brookings as saying is, well, they've gone model shopping. And it's a wonderful term. Model shopping is looking for a model that will justify your conclusion. That's using the veneer of science, but it's actually for advocacy. The problem was they couldn't find any model that gave them the result that they want. So it's actually, it's quite an interesting article to read. Wishful extrapolation. Wishful extrapolation, as an example of that, I will go outside of economics and talk about FDA drug approval process. And this may not occur to you, but I've written quite a bit on this, I should say. I actually do a fair amount of work on medical decision-making, public health under uncertainty. And the issue with the FDA, with all of the focus on randomized clinical trials as the gold standards, even if the randomized trials are done well, there remains enormous problems of extrapolating the results of randomized trials from the subject populations that the FDA uses and from the way treatments are structured with double blinding and so on to what would happen in actual clinical practice. So I call that wishful extrapolation. Very briefly, a couple of others. Illogical certitude are actually deductive errors. And the example I use is about research on heritability. It's on the contribution of genetics and environment to social outcomes, where I think it's clear there are deductive errors in the research. Now, all of the problems that I've just discussed relate to the research that's done. But the media plays a very important role in this as well, of course, because it's quite rare for the public to directly read articles in the American Economic Review or Econometrica or any PNAS or any technical journal. The role of the media is very, very important. And the media sometimes faces the same incentives that researchers do to overreach and to push things more than they should. Now, I said something nice about the New York Times a few minutes ago, so now I'll balance that. My poster child for media overreach, and you can go to my book and see they get the exact, there's a page 1 article in 2010 saying that if you have good kindergarten teachers, then that will increase your lifetime income for a kindergarten class by $320,000 exactly. Okay, you can go look at that and see what I mean by media overreach. Okay, in the time I have left, let me talk a bit about CBO scoring of legislation. Most of you probably know the CBO was set up in 1974, and the act has been interpreted as mandating the CBO to provide point predictions of the budgetary impacts of legislation, and the CBO director does that in letters to the leaders of Congress. These letters are not accompanied by any measures of uncertainty. Here's my example, and this goes way back. I used it in my book. This is Obamacare, the original Affordable Care Act. This is what the CBO's, the JCT, Joint Committee on Taxation, was involved as well. They estimate that enacting both pieces of legislation, because there were two bundled together, would produce a net reduction of changes in federal deficits of $138 billion. Over the 2010-2019 period. It's $138 billion, not plus or minus $5 billion, not plus or minus 50, 500 billion. Who knows what kind of margin of error to put on this thing. It's going to reduce the deficit by $138 billion. Bring that up to date to the spring of 2017, and the Republicans, repeal and replace effort in March of 2017. The CBO says enacting the legislation would reduce federal deficits by exactly $337 billion over the 2017 to 26 period. In this case, the CBO accompanied it by a verbal statement of uncertainty, which you can read here. And the verbal statement's fine, but there's no quantification of the uncertainty. And that's the big problem. Now, what I've done is I've advocated, I've written about this, I gave a seminar at the CBO on this. I say, look, let's be transparent about it. You know this uncertainty, why don't you express some of the uncertainty? There are different ways you could do it. You can do it in a probability distribution and this or that, but the simplest way may be just a simple interval, do a best case and a worst case analysis. And it seems sensible to me, but it doesn't necessarily seem sensible to other people. And when I talk about this to other people, I get two reactions. When I talk to academics, they say, sure, of course the CBO should be expressing uncertainty. And I will tell you, the CBO analysts are very good people, the PhD economists. I've taught some of them. They're really serious. They're trying to do the best they can, but they perceive that they can't do this. Academics react positively, but they say we can't do that. And I can't even tell you, I don't want to name anybody, how many people have told me that members of Congress are psychologically or cognitively unable to deal with uncertainty. I have heard that repeatedly. And I say, is there research on this about how members of Congress deal with uncertainty? No, but that's a strong perception. Another possibility, it's a little more subtle, is there may be a game going on, and that expressing uncertainty can make things worse rather than better. I mean, that's very complicated. Okay. Now, the other thing I was going to talk about, but I think I'm going to just skip because of time, is about estimation of GDP growth. I'll just mention very briefly. I have to have one slide, one graph. That's it. So here's my one graph. When the Bureau of Economic Analysis puts out GDP growth estimates, they're constantly revising them, but they're always giving point estimates, despite the fact that they know they're going to constantly revise them. It turns out you don't have to do, you think if they know they're going to revise them, then they should express uncertainty rather than just saying, here's our point estimate today. It turns out in the United Kingdom, they actually do express uncertainty. This is this is called a fan chart. It comes from the Bank of England, and what's up over here is actually a prediction, so that's a graphical prediction of probability. But what's over here to the left of this is on what GDP growth was in the past, but it's the probabilistic prediction of the Bank of England of what the future revisions will be. This is quite wonderful, and it's actually accepted in the British media, at least the serious financial media. Okay, let me finish with just two things. One, a question for research, is that we actually have, let's say you do things the way I would like, which is to express uncertainty. What would happen? I keep asking around, but it seems to me we have very little understanding of the way that users interpret policy predictions in official statistics. Some people may take them at face value and just be naive and not realize there's uncertainty. Some people, obviously when I talk to my colleagues, they say, of course there's uncertainty, but they don't know the direction or the magnitude of the errors. So I put here in italics, how would transparent communication of uncertainty affect policy making and private decision making? And I don't know, and I just leave it as a question. Postscript, since I'm essentially out of time, is to bring this up to the moment. Policy analysis in a post-truth world. You might think that worrying about uncertainty is kind of second-order problem today, when you just have people, unnamed people, just faking it and saying all kinds of things that are outright clearly untrue. Then why worry about uncertainty? But I think there's a very serious issue here that once you accept incredible certitude and take numbers at face value when then they shouldn't be, that there may be a slippery slope from incredible certitude to utter disregard for truth. So I do not think this is a second-order issue. In fact, I think it may be even more important to face up to uncertainty today than in the past. Thank you.